Have you ever tried to imagine the fourth dimension? It's a real mind bender, right? Well, today we're not just going to imagine it, we're going to build our very own four-dimensional object, a tesseract, using code. Are you ready? Let's get started.
So let's start with the biggest question of all. Can we actually see the fourth dimension? The ideal might feel a little tricky, but don't worry, we're going to explore the answer together using the power of code. Okay, so what exactly is this thing we call the fourth dimension? To understand it, we've got to go all the way back to where it all begins, dimension 0. Everything starts with a simple point. That's 0 dimensions. Now, if you drag that point, you get a line. That's the first dimension. Take that line and move it in a new direction, and bam, you've got a square, which is 2 dimensions. Now pull that square up into a third direction, and you get a cube, the basis of the world we live in. So here's the real question. What happens if we move that cube into a fourth direction we can't even imagine? Well, that's when you create a tesseract. And here's the key idea. A tesseract is basically the shadow of a four-dimensional cube cast into our three-dimensional world. Just like the shadow of an object on a wall, we can't see the real thing directly, but we can draw its projection. And that projection usually looks like two cubes, one inside the other, connected at the corners. So, how do we take this abstract idea and make it real? The answer is simple, with code. Now, let's take a look at the tool that's going to let us create this four-dimensional shadow, a program called OpenSCAD. OpenSCAD is a free program that lets you create 3D models by writing simple commands instead of drawing with a mouse. So we're not going to be working like a sculptor, but more like an architect, giving instructions to build our creation. You know what the most powerful part of OpenSCAD is? It's parametric. That means you control your model using numbers. It's just like customizing a character in a video game. You just change a few numbers, and you can instantly adjust your model's size, shape, well, everything. All right, we know our tool, so it's time to get our hands dirty. Let's start building our tesseract by coding its most basic part, our very first cube. A cube is actually pretty simple. It has 8 corners, or points, and 12 edges that connect those points. All we have to do is tell the program where those points are and which ones to connect. We start by defining the corners of our cube. Each set of x, y, z numbers in this points list is basically an address for a corner in 3D space. It's just like coordinates on a map. This way, the program knows exactly where each corner is. And this part right here shows you exactly how the code works. This edges list is just a set of instructions telling the program which points to connect. For example, 0, 1 just means draw a line from point 0 to point 1. It's that simple. And just like that, the skeleton of our cube is ready. We've learned how to make a single cube. Now, let's take that knowledge one step further and create our main goal, the tesseract, those famous 2 cubes connected together. The first step is super easy. We just use the cube drawing command we just learned to create our first or outer cube. A single line of code is all it takes. For the second step, we use the exact same cube drawing command again, but this time we add a translate command in front of it. This command basically picks up the second cube and shifts it a little bit to the side, up, and forward, placing it inside the first one. And here comes the most magical part. This code uses a loop to connect each corner of the outer cube to the matching corner of the inner cube. So corner 0 of the first cube connects to corner 0 of the second, corner 1 connects to corner 1, and so on. These connecting lines are the representation of the fourth dimension in our world. Our tesseract is ready, but the most fun part is just getting started. Because now you can change this model and create your very own tesseract. Right at the beginning of the code, there are a few variables you can easily change. Edge length lets you make the cubes bigger or smaller. Offset amount controls how far apart the 2 cubes are. And rod radius sets the thickness of the edges. This is where the beauty of parametric design really shines. As you can see, by changing just one number, you can completely redesign the look of the model. You can make the cubes almost merge into one, or build a giant tesseract. The control is completely in your hands. Today, with the power of code, we didn't just draw a shape. We made an abstract concept like the fourth dimension, something we can actually see and touch. And this is just the beginning. So what if you use this code not just for a tesseract, but maybe to try and create the shadow of a fifth or a sixth dimension?
Just remember, how many more dimensions are out there left to discover?